So for a little, this is going to be review. But if it's tough, just, I get it. There's rest after summer and stuff. It's cool. But I'm going to teach a concept approach to remember how to do things, okay? So we're going to start relatively simple with like a 1/2 plus, let's do 3/4. And so I like to start with this model approach where what 1/2 means is like half of something. And what 3/4 means is 3 out of 4 of that same something. Okay? So these are the two things I'm trying to add together. The issue is 1 out of 2 the same thing as 1 out of 4? It's not the same thing. So I can't, the most common wrong thing that I get kids to write is like 4/6 or something. Okay? You can't do that because you can't add up what we currently have because they're not the same. Right? I mean, this is 1, but this is, do you see how this is bigger than these individuals? Right? So I need them all to be the same thing in order to add them up. It'd kind of be like having a quarter and a penny and saying I have 2. We have 2 coins, but it's not 2 cents, right? They're 2 different values. My 1/2 and 3/4 are 2 different values. I need to get them to be the same value. So how can I get them to be the same value?
Find a similar
Denominator, right? So is there any way to make my 4ths into halves or my halves into 4ths? Yeah, I can get my half to be 4. So imagine cutting it like this. You guys see that cut? So if I make that cut, how many 4ths do I have on that first one now?
2.
Yeah, so 1/2 is 2/4, right? Conceptually, when you get that like denominator, that's what's happening. You're taking that half and making it into 4ths. 1/2 is 2/4. You guys seeing that on the picture? The reason I like the picture is I don't make the picture every time forever, but once we understand why we're getting that denominator, we remember to get it when we add, okay? So now I'm going to look at this and I'm going to say 2/4 plus 3/4. So you can kind of imagine that. Take this 4th, put it right here. What's going to happen with this leftover 4th? You're going to have to start a new thing, right? So that's why you're to get 5/4. I'll count them for you. 1, 2, 3, 4, 5. You're at 5/4, right? But you can use this 4th here to kind of fill out this, and that's 1 whole. This extra one over here, that's why 5/4 is the same thing as 1 1/4. I would take either one of those answers personally. All right? They're the same thing. So once you start building things on concept, I'm not saying make a model for everything forever. It actually kind of be more work than you'd want to do with some denominators. But when we understand the concept, it makes us get those like denominators. All right? Let's look at another one. Let's do -5/7 plus, let's do 3/5. So I'm doing this one to show you bad idea to try to draw this one out. Because if I have a denominator of 7 and a denominator of 5, what's like the only denominator I can get those both to be, or the easiest one? 35. And so you don't want to sit there and cut 7 chunks into 35 chunks. You're sitting there your picture's not going to make any sense by the end of that, right? But the same idea is I need to get them out of the same chunks. So organization, let me show you what I do here. I write everything out for my new fractions except my numerator. See what I did there? I know I want a denominator of 35. You could also use a denominator of 70. It's just going to be more work. And then I just slow down and I say, how did I get my 7ths to be 35ths? How many times more do I need? How do I get from 7 to 35? Times what? 5. So I'm going to multiply both numerator and denominator by 5. And there's my 25. What's true about this fraction and this fraction? What's true about it? The 2 fractions I circled in red, what's true? They're the same exact thing. We're just being like math masters and making them do what we want. But they're the same. I haven't changed any value. Let's look at these other 2.
You would just times it by
How do I get from 5 to 35?
Would it be
Just times it by
7.
yeah.
Okay? Then I'm going to get 21 35ths. Now here's what's going to be another little challenge is now we have to use the same integer operation understanding. So are these two fractions going to fight or hug? Fight. And who's going to win, James?
The negative
By how many?
4.
So my answer is negative 4 35ths. Cool? Go to concept. Go to concept. All right? Use concept. Yeah. All right, here's the next one I want to look at. Negative 5/6 plus negative 3/8. I want you to take about 15 seconds and talk as a table what denominator you think we should use. So after hearing those recommendations, I'm going to choose 24. Well, Sam, you could use 48 and get the right answer, but you're going to have to simplify your answer later. So I like using what's called the least common multiple. Have you guys heard that? So that's the smallest denominator you can use. So for organizational purposes, I like to rewrite my problem with my denominator there.
Isn't that where we do like the 6 and 8 and see like the number? Like do like.
The smallest one, you can get them both be with a
Yeah, 'cause
multiple.
we would do like.
Yep.
Maybe like 6.
Yeah. So how do I get to that multiple of 24 from 6? I multiply by 4. And to make my equivalent fraction, I also need to do that to my numerator. And that's where I get that negative 20. For that 8, how do I get from 8 to 24? Times 3. To make my equivalent fraction, I'm also going to multiply my numerator by 3. So now with my negative 20 24ths and negative 9 24ths, are they going to fight or hug?
Huh.
They're going to hug. They're going to hug it out. We're going to get negative 29 24ths. What that means, though, that numerator being bigger, it means there's a whole number there, right? How many 24ths makes one whole? Because I'm going to pull a hole out of there. How many 24ths is one whole? Billy?
Isn't it just 24?
24 of those will make 1. Because 24 out of 24 is 1, right?
So it would be 5.
So how many would be left over after that?
And then 5 over 20.
Yeah, 5 over 24 would be left over after I pull out that one whole. So I would take either one of those for me. But do you guys see how even when I talk about this, I point to concept? When we're making these denominators right here, it's no different than you making that Kit Kat into fifths. You acknowledge one bar could not be made into something to split, so you cut it into things that could be. That's all we're doing when we're adding, subtracting, and getting like denominators, all right? Cool. It's just Kit Kats.
We have some Kit Kats.
I do not have any Kit Kats for you.